Let's consider some additional facets of the residential housing market. In particular, let's talk about expected house prices. So, in order to measure the expected rate of appreciation in house prices, which we may abbreviate as EAHP, we're going to take the house price that's expected at the end of year one, or HP1, and subtract the house price in year zero, or HP0. And then we're going to divide that whole thing by HP0. And that's going to give us the EAHP percentage, the percentage expected rate of appreciation in house prices. Now, if we wanted to just focus on home equity, we could take that same equation and in our denominator add 1 minus L over V, which is the loan to value ratio. And if we do that, then we would have the expected appreciation rate on home equity as a percent. And we'll go through some examples in just a minute. But another concept that's related to this that we may want to keep in mind is the wealth effect. So we talked before about the factors that impact housing prices. And so they were all positive except for interest rates. Remember, if interest rates go up, housing prices go down because, or at least the demand goes down because they become more expensive because interest rates represent a cost of home ownership. And so the wealth effect just says that as income goes up, prices tend to go up. And so this is the effect that this expected appreciation in assets or home equity. So these two measures that we've just walked through the formula for, this wealth effect is the effect that these measures may have on consumer spending on other goods and services in the economy. So this means that as consumers start to feel better or more secure about the future, then they spend more. And we also see a reverse effect when consumers aren't feeling good. And so we see a reverse wealth effect because they spend less, and that tends to drive prices down. So let's take a look at an example. And in this example, let's assume a $100,000 property is financed with an 80% loan and house prices fluctuate the way I've got in this table. So we're starting off in year zero. Year zero is always today. But we're expecting that house prices are going to appreciate by 3%, 2%, and 4% over the next 3 years. We're financing, remember this, with an 80% loan, which means that we've got 20% in equity. So on a $100,000 home, that's $20,000 in equity. So now, using our formulas, we can calculate this annual appreciation in home equity for years 1, 2, and 3. So if in year 1, the appreciation rate is expected to be 3%, then that means our home value is going to go from 100 to 103. And so that means our equity is going to go from 20,000 to 23,000. So we would calculate that EAHE as the difference in the home price. So that's going to be the $3,000 in appreciation divided by the original home price times 1 minus the loan to value ratio. So original home price was 100,000, loan to value ratio was 20%, so that gave us the denominator of 20,000. So our annual EAHE for year 1 is 15%. And we can follow that through for year 2 and year 3. So year 2, now remember, we're not going back to 100. We're showing the appreciation from year to year. So in year 2, the home is appreciating in value by 2% over the 103,000. And then the same thing in year 3, it's appreciating by 4% on the 105,060. So now we can ask the question, well, then what is the unrealized annual rate of appreciation on equity in this example? So considering the full 3 years, not just year to year, then what is the annual rate of appreciation? So now this is going to be a time value of money question. So our N is equal to 3 because we've got 3 years. The present value is that equity that we start off with. So that's the $20,000. Payments are 0. Future value is the $29,262 in equity that we end up with at the end of year 3, and then we solve for the interest rate, and that is 13.53%. So we're just looking for the growth rate in the equity. So when we are analyzing these expected house prices, there are going to be different influences on these prices. There are regional economic influences. And so when we're analyzing real estate, we've got to keep in mind these regional economic drivers. So we've got to figure out what they are. We need to identify those drivers because that's going to vary from region to region. And then we have to make a judgment call about whether or not the drivers that we've identified are going to provide a source of growth or a source of decline in that particular region. Also, we have to think about the law of comparative advantage. So those markets that have industries with the highest likelihood of future growth are going to have a positive effect on house prices. So we have to look at the industries in that particular geography to estimate what might happen in the future with those industries and how it would impact the housing market. And then lastly, another last thing to consider here is the driver or base industries in that region. So we need to identify those businesses that produce the greatest profits, or we could use employment data as a proxy for this. So here's what we mean by this. When we're doing an economic base analysis, we're going to use this formula. And what we're doing is calculating location quotients. And so it's more of a relationship than a formula. So what you're seeing here in the numerator, we have the regional employment the regional employment in a particular industry, so industry J, over the total employment in that region. And we're considering that ratio to U.S. employment in that industry versus U.S. employment in total. And so what we're doing is we're looking to see how, once we plug in our numbers, we're looking to see how our numbers compare to 1, meaning base employment is in industry classifications, those J's, with a location quotient greater than 1. So that formula will help us calculate our location quotient. And if we come up with a value greater than 1, then that's the base employment in that region. If our location quotient is less than 1, then that's going to be supporting employment. So those are industries that are important, but they're not key drivers like the base employment. And so total would just be the base plus all of the supporting employment.